But either way, so we're going to be talking about this particular paper and kind of it covers just the implications for consumer health and research moving forward, as there is still a lot to be discovered in this area. So, a little bit about my background. I got my degree in neuroscience from UC Santa Cruz in 2012, and pretty much immediately started working in cannabis testing at SC Labs, even prior to graduating. Started as an intern, became a lab tech, and then worked my way up to become a lab manager. And I've been involved here with CAN since 2016. I left SC Labs in 2000 and around that time in 2016. In early 2017, started doing some consulting, doing a lot of different things in testing, ISO, method validation, SOPs, and also doing a little bit of formulation and extraction too on the side. From there, I joined a company called Medicinal Genomics. There, I focused on cannabis microbial testing, and that's where I learned a lot of my chops about cannabis microbial. And also, we focused on cannabis genomics as well, producing the Jamaican lion genome and doing a lot of different sequencing to kind of understand the genetics of cannabis and the lineage. And so that you can see here on the bottom left, that is StrainSeq, which is on Cannapedia, which is where you can kind of look up different cannabis genetics and understand their relatedness to each other. From there, I kind of made a switch and used my background in testing to help develop something called TagLeaf. TagLeaf is a lens powering the cannabis industry, and a lot of the labs in the country are using it, and about 20% of the COAs in the marketplace are going through TagLeaf at this point. From there, made another switch, ended up going into academia, worked at the Skaggs School of Pharmacy and Center for Medicinal Cannabis Research, where I started to help set up the reference laboratory for the state of California. But then I decided wasn't really my thing. So I decided to move back to industry, and that's how I landed where I am now at the Food Science Division for Bio-Rad. And I am responsible basically for all the field cannabis efforts at Bio-Rad for the IQ check assays, automation, and things like that. So I'll go ahead and start with the paper. So this is a really great paper. Firstly, I do want to mention that this group of four, they really are kind of the real experts, I would say, in terms of like the research area, the research side of things, and really kind of uncovering what we really should be looking at. And they gave me a lot to think about with this paper. So to dive right in, with the cannabis plant, we have, I guess, some terminology: epiphytes, endophytes, and phytopathogens. So A, B, and C. So epiphytes are things that reside on the outside of the plant. And that is kind of part of the what is native to the plant, and just exists there naturally. Then you've also got endophytes. So these are also endogenous and they reside within the cannabis plant. So these are things that typically things like plating are probably not going to pick up because they're actually within the plant itself. So you actually have to use a molecular method to really understand what is going on in there. You can do some dissection and plate from there, but again, culture-based methods are kind of fall short on picking up endophytes in a lot of ways. And then we've also got things like phytopathogens. Um, Phytopathogens are not really, what you don't want, right? So I guess a good example I could give of this is something like botrytis, right? Something that is not going to be beneficial to the plant, that causes problems for the plant, and typically results in a reduced quality product as a result. So we've got a bunch of different fungal pathogens that we find in the cannabis microbiome. So fungal human pathogens do cause these things called mycoses. And so here's some different examples of mycoses in the figure on the right. So you can get things like aspergillosis or mucormycosis or fusariosis. These are all associated with different pathogens of interest that we find within cannabis. So just some examples of those pathogens and the genuses here listed here. You've got things like Aspergillus fumigatus. Aspergillus fumigatus is probably the number one source of aspergillosis. But we also have things like Penicillium citrinum here next to it, that produces a mycotoxin called citrin, which we'll talk about in a bit. There's also Fusarium oxysporum. Fusarium is probably well, what I'm seeing now is a very prevalent cannabis pathogen that reduces and affects quality and yield, and is really just kind of seemingly pretty widespread. And then we've also got Mucor indicus on the right there as well. And these um, these fungi do produce mycotoxins, which is kind of going to be the focus on today's talk. So, what are mycotoxins? Mycotoxins are secondary metabolites that are produced by various different kinds of molds, and they can cause disease in animals and humans. And mycotoxins are heat stable. And so they don't really degrade after processing through things like distillation, hence why they are definitely of interest in understanding, what could be hanging around after we do these types of processing methods. So most states with legal cannabis frameworks do currently test for mycotoxins. We test for five, specifically four aflatoxins, B1, B2, G1, and G2, as well as ochratoxin A. And the action levels for these are 20 ppb. Some states, depending on where you are, some specify at exactly 20 ppb being the threshold. Others specify that it needs to be less than 20 ppb. So just a kind of a minor detail that and nuance between the different state regulations. So with this paper, they kind of take a look at the overall microbiome. So that is, right, like what are all the fungal populations within the cannabis plant? And then they kind of zoom in and say, all right, what is the mycotoxin potential of each of these and what is the relative abundance? So I've got highlighted in red some of the ones that we saw in the previous slide and the relative abundance. So really, you kind of want to focus on what is the most prevalent and then what also has the highest potential for producing mycotoxins. So here, right, you can see Aspergillus flavus. You've got three pluses. That means it's got a very high potential for producing mycotoxins. In the penicillium arena, we see that Penicillium citrinum, which has two pluses. And then you can see very clearly also that that one is very prevalent. It's got, there's 20 to 30% relative abundance. And then also we've got Fusarium, which also, again, a lot of pluses. We've got Graminearium. We've got, I'm not going to even try and pronounce it because I'm going to butcher it. But as you can see, these aren't found in necessarily the highest abundance, but they are there. And also things like Oxysporum, which I mentioned earlier, at 5 to 10%. So again, I think this paper does a good job of taking a look at the high level and then saying, okay, where do we need to zoom in further so that we can better understand if the toxins that are there are produced, or if the for the fungi that are there, if there are toxins produced. So if we look at kind of the different fungi in the microbiome, and then also some of the kind of illnesses that come about from them. So here's a decent list, and I wrote a book chapter called Cannabis Microbial Testing Methodologies and Considerations, and I've got like a huge list of these. This is like not all inclusive of the different mycoses that can result, but you can see there's quite a bit. A lot of them focus in the area of Aspergillus, and like I mentioned, Fumigatus being kind of like the most prevalent for causing some sort of illness or disease. So aspergillosis mostly, but also things like allergenic responses. And there's a variety of different methods that we can use to determine that these were indeed the causal agent of the condition. So these are just the references here. So you can see that mostly Aspergillus, but there's also Fusarium that causes issues. Things like Alternaria too can cause allergic responses. And then this one at the bottom, Cryptococcus, this is actually a really unique one, and I actually used to highlight this a lot in some of my talks. This one came from a situation in Bakersfield where this woman liked to smoke blunts, so she would buy like the cheapest weed she could find from her dispensary in Bakersfield, and it actually ended up causing her to get cryptococcal meningitis, so that's inflammation of the brain, and it almost killed her. So again, like we test for a lot of things, you can't test for everything, but this one was kind of like one of those oddball, like, whoa, that came out of left field and it really almost really hurt somebody. So again, you looking at these kind of microbiome examinations can kind of inform us as far as what we really should be looking for and why. And I think it's important that we look at that because that can really help inform policymakers as to what to really be looking for. So as far as mycotoxin potential in the Aspergillus category, so here is a lot of different Aspergillus species and the different types of mycotoxins they produce. So as you can see, aflatoxins and ochratoxin are included there, but also things like botulin, gliotoxin, trichothecenes, and there are others as well, which are not listed here, but there are many, right? I think we focus on the aflatoxin and the ochratoxin A because those are really going to be the most harmful to human health. As you can see, 20 ppb, like I mentioned earlier, is the max limit for these things. So very small amounts can be very, very bad for human health. And they come with, like I said, a host of health issues. So liver cancer, mutagenic, immunosuppression, hepatotoxic, and nephrotoxic in the context of aflatoxins. In the context of ochratoxin A, these are carcinogens and could produce tumors. They can also result in really bad kidney damage. So yeah, these are not great things to have in your cannabis products. And if we move over now to things like penicillium, penicillium does have a lot of overlap as well. It's very closely related to aspergillus, so it does have a lot of overlap in the things that it does produce. So there's no aflatoxins listed here, but there are things like ochratoxins. And then we've got things like citrinin, and we've also got, it's not listed here, but also things like paxilline. And then there's other alkaloids too that can cause problems. So just to kind of give some of the highlights on some of these things and what they can do. So I think penicillium citrinum, excuse me, being the most common in the cannabis microgram, one of the most common, at least species there. This is probably something that we would think to look for. The FDA regulations for this are 20 ppb in agricultural products, and again, a host of health issues associated. We've also got Paxilene, which is from Penicillium paxilli. And that was going to be important for epilepsy in particular, because it basically affects the ion channels and such that, right, if you're using something like CBD, say, to control your epilepsy, but it's contaminated with something like Paxilene, well, then you've basically got a recipe for more epileptic episodes. So that's something that you would want to consider there. And then we've got things like botulin. So this is actually normally something that we find in things like apple juice. So apples have an issue with botulin being a contaminant, and the FDA regulations for that also, again, 20 ppb seems to be kind of like the general number that people like to go with. And that also causes a host of other issues like nausea, vomiting, and GI issues. And then, like I mentioned, the ochratoxin A, again, there's that overlap between aspergillus and penicillium there. So you will, which makes sense why they would mandate to test for that one in particular. So, and then we move over to things like Fusarium. So here we have a lot of these different Fusarium species. And as you can see, there are a lot of different mycotoxins associated with Fusarium. The type A and type B trichothecenes are probably going to be the most common ones that you encounter, at least which I'll show you in a future slide, what we're looking into more closely. So that includes things like deoxynivalenol or vomitoxin, or things like Nivalenol, its derivatives. There's acetylated forms of these things. There's quite a bit of kind of variations within. And then there's also things like fumonisins. Fumonisins can cause nausea, vomiting, and reproductive health issues. There's also things like zearalenone. Zearalenone, while there isn't any limits on zearalenone, it is an endocrine disruptor. So think things like BPA, things that can kind of mess with your hormones, and kind of well, really just mess with, yeah, your endocrine system in general. And then there are a bunch of other emerging mycotoxins as well. Again, I'm not going to go too deep into each of these, but there are more of these that we're finding out do have impacts on human health. And as you zoom in, right, like which are the ones that cause or have a lot of potential for mycotoxins, those are the plus signs that indicate that there. So how do we actually measure mycotoxins in cannabis? So there's a few different ways we can do that. I think what is most common in cannabis testing labs is using the LC triple quad, but there are kind of different renditions of mass spec that you can use for that. So the advantage of using an LC triple quad is that it's super sensitive and efficient, and you can get really kind of mass specs are really kind of like truth detectors. So if it's there, you're going to see it. If you have a standard and you confirm it, you can say kind of indisputable without any kind of dispute, right? That these things are actually there. They're present because there are mass transitions and things like that. Some disadvantages, though, is that the extraction analysis can be time consuming. Depending on your extraction method, you can get different results. Also, because cannabis is a really complex matrix and you have like a giant THC peak or CBD peak or whatever, active that you're looking for that kind of muddies the water there. And also all the other components that are in there, it can really be difficult to get good data out of that. And that's where method development is really important to really kind of make sure that that you can pick up these things in matrix. And of course, cannabis has a zillion different matrices and different product types. So again, where method development really comes in and is really important. And in general, you do need trained operators, and mass specs are not cheap. If you have $250,000 lying around to get a new one, you can get a pretty good one, but again, they're yeah, not cheap. You can also do LC with fluorescence detection, also with UV as well, as you'll see in a later slide. And this is going to be effective for specific known mycotoxins, but there is kind of some prep work that goes into that in order to actually detect them. They're not as sensitive as the LCMS, so your limit of quantification is going to be a bit higher with that type of method. And all these at the top do require organic solvents, so that's another thing to consider. But then you've also got things like ELISA. ELISA's a rapid, effective test for a lot of these different compounds, and there are test kits available for other crops that we use in cannabis. But again, these aren't really like our go-to way of doing this. There aren't really any certified ELISA methods for cannabis. And it's kind of limited to what you can do in terms of like you need a specific anti-sera for these toxins in order to actually look for them. So again, I think really kind of the gold standard would be using that LC triple quad. But if you don't have an LC triple quad and don't have the big bucks, LC with fluorescence or UV could be helpful here too. So what are some factors in mycotoxin production and presence? So I think temperature, of course, is one. Molds like to grow at different temperatures. There's certain ranges where they like to thrive and other temperatures where they don't. Also, water activity. Water activity is incredibly important for any type of mold or bacterial growth. In general, microbiological contaminants in particular, because basically water activity is that measure of how much water is actually available for the microbes to grow, because there is moisture content, and water activity differ in the sense that moisture is overall how much moisture is there, whereas water activity is more so like how much is actually available, because a lot of that water is bound up and not available for microbes to grow. So that comes out in readings in what we call AW values. So typically on the flower side, we try and keep the water activity below 0.65. And then relative humidity is, of course, also important as well. How humid is the environment? So in a place like Florida, yeah, like of course, it's humid. You're going to see a lot of mold and other microbial contaminants in places where it's going to be humid. But if it's dry, probably going to be less. pH to a point, right? Lower pH, or trending towards lower pH can yield higher production of these mycotoxins. And then, of course, your substrate that it's growing on. Cannabis has a lot of different antifungal and antimicrobial compounds within it, things like the cannabinoids and terpenes. So, of course, it may or may not grow, right, depending on what your substrate is. And then I think what's important too to look at is this cannabis or hemp? Um, the reason why I say is it cannabis or hemp, like cannabis has these rules and regulations for things like water activity. Cannabis has rules for microbial contaminants. Hemp has none of these. Hemp is pretty much completely Wild West. And in general, hemp products are treated, or how people deal with hemp is a lot different than how people deal with cannabis. A lot of people just grow hemp and buck it, chuck it, and then send it off for extraction. And that's kind of where this concentrated products comes in. I think we're really going to see a lot of these mycotoxins more so in things like concentrated products like distillate or hot dog water. So here on the right, I've got a distillate pen. Really, they call this hot dog water because you are literally taking all the little bits and pieces that people cannot sell or undesirable material. Maybe it's gross. Maybe it's been just hanging out on the floor. People just kind of throw it all in, run it through ethanol, and then distill that accordingly. And then you have a vape pen. Some steps in between. But obviously, this is kind of where I would say the biggest health concern is these distillate pens. And so next, I want to kind of look into what are the trends that we actually see across the US in terms of mycotoxin detections? Because as I mentioned, we test for 5 of these. Keep in mind that this 10 state plot here is flower only, and I want to thank Yasha Khan for doing all the data analysis on this and also for procuring this data. So you can take a look and see all these different states and the amount of flower samples that were tested for toxins. It's a pretty big sample size. I mean, 427,971 data points. I think we've got a pretty good, kind of landscape and understanding now when we have almost 500,000 data points to draw upon. So here are the number of samples that failed in each respective state. So Overall, 59, not that many, Nevada being the highest, which is interesting considering what I mentioned about humidity, Nevada being a very hot and dry place. But Washington would be the next highest, and that's at 7, so makes a little bit more sense. And then the number of samples in which toxins are detected, I think that's a big difference. See, we hardly ever see anything above that 20 ppb action level, but we do see a ton of low-level detection. So this is again why I kind of labor the point of, yeah, flower, probably not a big deal. Extract, probably a big deal. And especially in places like Nevada, again, really high levels. Washington also, or sorry, really high detections. Washington also really high detections. And in other states, Maryland, Oregon, Missouri, we do see some detections, but again, so less than zero, but not above that action level. So again, if you actually crunch these numbers, Washington being at 20%, Nevada being at 13%, a total detection rate of a little bit under 5%. So again, it's there, but is it at anything that's a harmful level? Really kind of seldom below so at 0.01% there. And then if we look and drill deeper in terms of like segment this out, well, are we looking at aflatoxins versus ochratoxin? Again, here's our total sample size. So again, over 400,000 data points. We have 19,982 that have detected levels of ochratoxin A. This is the one that you see the most commonly over the aflatoxins. So you can see that's percent detected at a little under 5%, but the actual amount that fails, again, is 0.01%, and even lower for the aflatoxin. So again, ochratoxin A would be the one you would probably want to zoom in on more over the aflatoxins, but again, still like they're not ever in flower really going to be anything that really fails. And again, I also want to labor the point that if you have a flower that is going to fail for aflatoxins or ochratoxin, it's got to be really gross, like visibly gross. And you also do microbial testing up front to kind of rule that out. So total yeast and mold is valuable in that context, not always valuable. I have my qualms with total yeast and mold. Um, but we test for things like pathogens, and if they are in any like significant amount, right, you would think that um, that would fail testing up front before it would fail for mycotoxin testing later. So that is just a point that I think is important to consider here. So if we look in my own state in California, this is not just flower, mind you. And this is only data from 2018 to 2021. The DCC, formerly at that point, the BCC, used to put out these nice handy little reports that would tell us, here's all the different batches that were tested, and then here's what they failed for, which was actually really informative and helpful. I wish that they still did this kind of thing. But if we look at the mycotoxins, there are only 12 mycotoxins out of 212,551 batches that were received. So again, it's a very low failure rate. But this, kind of begs the question, okay, well, we don't see those, but are we actually looking at the right toxins? And what really got me thinking more about this topic in general is this billboard here. I think this came on my radar somewhere around like 2018. You can tell that this is not a recent billboard, because look at the pricing. I mean, trim goes for like significantly less nowadays, but back in the day, you could get $269 a pound for your moldy flower. And what's crazy is they were just openly advertising that they wanted your moldy material, which is frankly kind of gross. But anyway, I digress. This was on, I believe, on 101 in California, NorCal, where you have had a lot of cannabis cultivators and, of course, a lot of moisture up there too. So they're like, well, let's see what we can get with this multi-flower. And again, this is still very early days of cannabis. Um, but Fusarium is the one I'm most fixated on, and there's a reason why I'm fixated on it, aside from what I showed you in the Punja et al. Paper. Um, there is like some very interesting stuff in our history that points to, hey, Fusarium's pretty prevalent, and they actually kind of used it as a means to eradicate cannabis farms back when. This is something that was published in the New York Times in 1999, where a group in Montana was contracted by the Florida Department of Florida Office of Drug Control to engineer Fusarium oxysporum to eradicate cannabis plants in their state. So again, this is just an article that I found when doing my research some time ago. I don't know if this Fusarium oxysporum ever got released into the wild, so to speak, but there were a lot of environmentalists that were really worried that if you unleash this, it's going to be really problematic, not just for cannabis maybe, but for other things as well. So Fusarium is definitely prevalent as we see in the cannabis market, and this is kind of a trip down memory lane from my time at Medicinal Genomics. Well, we knew this. We had heard about this from cultivators. We were like, what kind of tests do you want us to develop to help you in your cultivation? Fusarium was one that came up. And so I basically went out to some of these cultivation facilities on the Central Coast. I'm not going to name exactly where because would be probably be too easy to guess. But I went to this big cultivation facility to try and do some R&D to understand, okay, how does our test perform and how can we best sample this and understand? So I was taking leaf samples and stem cores, so leaf biopsies, but using a hole punch. And then I had these core biopsies that I was doing. And predictably, based on what we know about Fusarium, we saw that it travels from the soil and then it goes up the plant. So if you can think kind of Fusarium like something that really affects the vascular system of the plant. It basically kind of like it's like if you were to have blockage in your arteries or something, or blockage in your veins. It basically causes issues with nutrients getting to different areas of the plant and causes fusarium wilt. It can also cause fusarium blight. There are different kind of forms of fusarium and issues, different types of infections that you get. But again, when I went to this place, like even my negative controls were lighting up. I'm a microbiologist. I know how to do aseptic technique. I know how to keep things clean, but I said, give me a separate room within this facility where I can do this work. And even my negative control was lighting up. So that kind of tells me that this stuff was airborne, it was everywhere, and it was causing problems all over this cultivation facility. So again, like with these two things in mind, I started thinking like, well, who has actually done any work investigating this? And this is the first thing that actually came on my radar. So this is work from Columbia Food Labs. And this was a poster that was done at Cannabis Science Conference, I think around 2018 or 19. And they looked at a lot of different Fusarium mycotoxins, so fumonisins B1 and B2, as well as the type A and B trichothecenes. And in this, they reported that 1 in 100 flower samples tested positive for fusarium-derived mycotoxins, specifically deoxynivalenol and zearalenone being the most prevalent. Since then, I wrote my book chapter, and actually part of this I included because I actually reached out to McGuire after I found this poster, and I said, "Hey, like, have you done any further follow-up work on this? Because again, I think you're going to see it in extracts." And he did. It turns out he's no longer with Columbia Food Labs these days, but he did respond to me and said, "Hey, since that time, we actually have been testing a lot more of these, and things like extracts, and the 1 in 100 number is actually more like 1 in 15 to 1 in 20." And the majority of these are things like Nivalenol and its derivatives, so the DON, and the ZEA also as well is something that's common as well as fumonisins. And he even went as far to say is that fusarium toxins are far more prevalent than aspergillus in cannabis, which I thought was super fascinating as someone whose work focuses on testing for aspergillus in cannabis and cannabis products. So some more work that's been done in this area that is referenced in the paper that's being discussed today. They looked at different CBD products. So there were 10 CBD products that they looked at. 7 out of 10 of them tested positive for Fusarium mycotoxins. The most common being zearalenone, that's that endocrine disruptor. And that was at a max of 11 ppb, so pretty low levels. There was also 60% of samples being contaminated with zearalenone. And then, sorry, which I just mentioned, and then the 30% of samples contained this Eniantin B, and 10% of these samples contained also T2 toxin. Now, I think this is really interesting though, considering like a lot of CBD products on the market, I think probably the vast majority, not all, but a lot of them, and it's not listed exactly which products or what what the input was, but most CBD products on the market are made with isolate. So if in isolates, right, it's crystal structures. So in crystal structures, impurities typically get pushed out. So if there is that kind of level that we're seeing in something where it's made with isolate, like it's got to be really contaminated with some of these things. So again, something that is important to consider. And again, 7 out of 10, that's 70%. That's pretty common to see these things. Um, and so, what does the FDA have to say about fusarium-derived mycotoxins? So, in particular, things like deoxynivalenol or vomitoxin, they have an action level of 1 ppm in finished wheat products, and then in grains and grain byproducts, it's 10 ppm. Fumonisin, it ranges anywhere from 2 to 4 ppm, depending on the product that we're talking about. And like I mentioned, zearalenone, that endocrine disruptor, the FDA doesn't have any guidelines for this one, but again, it seems to be there in a lot of these products. So something to look into. And if you look at the actual chemistry of these things, it's not as likely that you're going to see them in things like hydrocarbon necessarily, because there's some polar groups here, as you can see on most of these. So water soluble or ethanol extraction, things like that is probably where you're going to see them most, which is kind of why I zoom in on distillate and hot dog water. That's probably where you're going to see these more often than not, I would think. And what's interesting too is there's this potential link to cannabinoid hyperemesis syndrome. So obviously deoxynivalenol is called vomitoxin. Nivalenol and T2 toxin also kind of have this when you're exposed to these things, they have this remarkable similarity to CHS and the symptoms that are produced from that. So we don't really know if this is something that is a causal agent. I mean, based on my understanding of CHS, there's a well-defined endocannabinoid system pathophysiology that is involved here. So I don't think that these are responsible, but nevertheless, it is a really interesting link. Who knows? It may precipitate that. We simply don't know. There's a lot that we don't know about CHS at this point. But I think this was a really cool thing that they pointed out in the paper that I wanted to highlight as well. So this is a brand new paper that just came out early last month, where they actually infected industrial hemp with Fusarium graminearum. This is the one that produces the deoxynivalenol and some other mycotoxins as well. And you can see that they did in this paper that they did pick up some deoxynivalenol and 15 acetylated deoxynivalenol. The study used LCUV, so the LOQs are a bit high. And again, considering what you could see on mass spec, you can get down to PPB or even PPT depending on the mass spec you've got. So they do highlight in the discussion section that, yeah, we detected these two, but there may have been others present, just not detected because of the fact that they were limited by their detector. So again, some food for thought to consider as well on that one. So there are some unpublished findings that I've been hearing about as well too. And so speaking with one of the authors of this paper, he mentioned to me that, and this I think some of this was teased at AOAC over the summer too. But he saw in certain markets that 1 in 6 cannabis hemp products contain fusarium-derived mycotoxins. While and so while that's it's a pretty decent amount. And then we've also got my group, the work that we're doing. This is still very early for what we're doing, and this was mixed matrices. This was not this was a mixed matrix. This was not like any one particular sample type. This was just flour or just concentrate. But early screening, 3 out of 80, 3.75% were coming back with fusarium-derived mycotoxins. We had a very, very large peak for deoxynivalenol, and we had 2 smaller peaks for zearalenone. Unfortunately, I don't have any quantitative data on that just yet. Like I said, we're still getting started on this. But there is going to be more on this to come. I'm going to be speaking on this at CanMed in Puerto Rico in June. So for anyone who wants to learn more about the ongoing work that's happening in the background here on Fusarium mycotoxins by my group, I'll be presenting on that data there. So with that, the paper does, and myself do have some conclusions, thoughts, and future directions. So more often than not, we're really not going to see aflatoxins or ochratoxin A in cannabis flower above the action level. The commonality of this is pretty low. Um, and then that kind of begs the question, does it really make sense to continue testing for these in flower? I think really we should be focusing on things where they're going to be concentrated, things like extracts, because that's where we would actually see them. And again, to kind of backtrack to what I was saying earlier about flour, like visibly, there should be visible mold present if you're going to see any type of mycotoxins in a appreciable quantity present. Um, but we do see, at least in cannabis flowers, that there are some mycotoxins that get produced. Are they in high levels? Not necessarily, but are they at levels that could be potential for health concerns? Yes, it seems like, based on the FDA regulations. And I also want to point out, right, that you don't smoke weed. Like, you smoke weed, you don't smoke weed, which was at a 1 ppm action level. So again, if and when you're smoking something, it's a direct shot into the lungs, gaseous exchange, and right into the blood, right? So that is an entirely different concern when you're smoking something versus when you're ingesting something. So I want to point that out that really we do need some kind of understanding of in how inhaling these things affects us. And I think just in general, and as the authors conclude in this as well, we got to look at some of these other mycotoxins that are produced by some of these fungi that we commonly find in the microbiome, because this is like a largely underexplored area. There's been very little work looking at this, but I think it's one of those that really has an important aspect to health outcomes for people. And we could be poisoning ourselves and we really don't even know it. Similar to kind of the pesticide issues where we look at, at least in my state, 66 analytes. But there are many other things that people use that could be harmful for our health that we're not even looking at. So um, with that, I do want to give some acknowledgments. My employer, Bio-Rad Laboratories in the Food Science Division, for allowing me to work on this kind of stuff in the background. Yasha Khan at MCR Labs for doing all the data analysis for the mycotoxin trends in this presentation. And then also I want to thank all the state governments that did provide data. It hasn't been easy, I know, for Yasha, but it's yielding some really interesting insights, and we're grateful for that. And also want to thank Wes McGuire with Columbia Food Labs for talking with me all those years ago and just and kind of giving me some food for thought to continue on this work today. And with that, here is kind of all my socials. I'm on ResearchGate, so you can find all my publications for free there, a lot of my presentations too. I'm on LinkedIn, so feel free to shoot me a message, or if LinkedIn's not your thing, feel free to shoot me an Instagram message. I'm on all of those things. And with that, we can kind of open up the floor up to questions.
Thanks, Kyle. Thank you so much for presenting. We have a question in the chat, and then also I have some things that I wanted to talk about. So this presentation is like a great review article and really focused on these limits and the action that we can take as scientist in the industry, but I also want to talk about how this has impacts on the rest of the industry because as people who have worked in testing labs, we're in a unique position and we have seen a side of the industry that a lot of people haven't seen. And so I want to bring it back to kind of like how this affects cultivators and manufacturers and the steps before we get to this where we're having to utilize resources and manpower to now do research on this because we realized that we might have been A, performing extraneous tests and then B, not performing potentially necessary tests. So how can we relate this back to the cultivators and manufacturers? And the authors of the review paper do mention some of this as like in pre-harvest and post-processing practices.
Yep,
Um,
yep.
can you speak to any of the relationships that you've had with cultivators or manufacturers, either in any of the roles that you've had, about how they approach this from their perspective about what they're doing to keep their grows clean and how they're trying to prevent this? Or are they just, like who is bringing this to their attention? Because you said you had some cultivators bring this to you about fusarium in the beginning.
Yeah, so I mean, right, an ounce of prevention is worth a pound of cure. So by taking the necessary steps to be clean in the first place, being careful who not just taking random clones from somebody where you haven't screened them and then bringing them into your grow room and then essentially like we have the same issue with things like hoplite and viroid where people are kind of unknowingly bringing in plant aids into their room and then suddenly it's like why are all of my plants dudding and dying and diseased? So upfront screening is really helpful to understand if whatever you're bringing into your clone room or your grow in general is safe and clean. So that's part one. Part two, right? Making sure you have just good practices. You need regular circulating air. You need filtration of that air if you're bringing it in. Like you need just general clean practices. Like, obviously, like not letting, the dog just run around in your grow room or just anyone running into your grow room that might bring in outside contaminants. And again, like I also think it's important, like which populations, right? Like you're working with as well. Obviously, like different populations are going to be more affected by this than others. So for recreational, maybe not as much of an issue, but still like an issue for general consumers. I would say, like especially on like things like on the mycotoxin side, like doesn't matter if you're immunocompromised or not; those are bad regardless across the board. And as far as like the manufacturing side of things, it's really like know your source, right? Like if you're if you're gonna go and like just grab any random distillate pen, um, and you don't know where it came from, like where the source material is from, and even if it's past safety testing, unfortunately, right? I wish we weren't at this point, right? Like I guess the science, right, informs us where we need to go next. While I think we've done a good job initially of like, okay, like here are the regulations and here's what we're going to test for, the more science we do, the more things we learn, the more we need to kind of shift our focus and think about do our policies even make sense? And I feel like what is great about doing this data analysis and the work that Yosh has done is it gives us things to think about, like what is working, what is not working. So again, that's from like the testing angles. But I mean, again, from the manufacturing side, yeah, it's like really like vetting who you're working with as well. Like, some testing labs will just pass things. Like, unfortunately, that's the truth. When money's involved, people will do all kinds of things. So it's just like, well, I don't see this, or that kind of thing. So there's a lot of different things that people can do, I guess, to try and implement best practices, both on the cultivation and manufacture side. And really, what that comes down to is just being careful, vetting things, and yeah, being clean.
And I
Um,
think that we can take that lesson and apply that to ourselves as consumers also. Like we get to choose who we buy products from, and it's not always easy as a consumer to understand where that company's priorities are, but I feel like, we can look to what's been happening in California with the recalls as maybe some examples of that. Would you agree with that?
Oh yeah, absolutely. I mean, like, I think a great example is like I mentioned, the Cat 4 movement. Like, we had no idea that, well, general consumers had no idea, and even testing labs, right? It's a blind spot. It's an entirely a blind spot for us. So, you only see what you test for. And so, of course, people in this industry are smart. Also, like we were previously black market and things like that. So people did, they figured out ways, right? Everyone figures out a way. So when you give people a list of 66, those are the 66 I know I can't use. What else is available to me? And so again, it makes sense to kind of revisit. And also, it kind of makes sense, I think, to start doing more of untargeted analysis too. Like, looking at, all right, here's like a bunch of different extractors and their products. What do we see come through on those extracts commonly? And what is not on that list of 66 so that we can better understand what cultivators are using. And so we can actually make policies that make sense that keep people safe. Right now, I don't
What
think
I'm,
there's nearly enough of that,
yeah.
happening.
What I'm hearing is you saying that we should look at the active market to inform our policies instead of deriving them off of other industries that are not as relevant to
That is correct.
cannabis
Yes.
as a unique food and crop medicine, etc. Um,
Mhm.
which I totally agree with. And we have a we have a question in the chat, and then I have another question. So someone asked, "Do we know how many samples failed for total yeast and mold?" And before you answer that, can you also let us know like what you think of total yeast and mold as a measure of safety and testing?
That's a really good question because I know there's a ton of controversy going on about this right now. So I have my opinions, and they are that total yeast and mold can be useful. It's kind of like it's a measure of bioburden, right? So yeah, if you have elevated TYM counts, that means that there could be something lurking in there that is a pathogen, something that could harm you and cause issues for human health. And again, I think it's important to look at TYM in the context of who is consuming it. If you're immune compromised and you've got a TYM of 100,000, that's risky, or above 100,000, that's definitely risky. If you are a regular everyday consumer, with a totally healthy immune system, and you have, I don't know, 50,000, 100,000. It depends on what these yeast and molds are in there. Like there's also like I think a point to be made that there are a lot of these that are actually like these fungi that are actually beneficial to the plant that work in harmony and in symbiosis with the plant, and they help produce some of these metabolites that we like, cannabinoids and terpenes, flavorants. We don't have any evidence for the latter yet, but I mean, I'm sure that there are going to be things that come out that inform us the more we look into this as far as what is beneficial to the plant and what is helpful. So as a measure of for consumer safety, yeah, I guess it makes sense for a medical patient maybe, but for someone who's completely healthy, it's it doesn't tell you if it's harmful or not. It doesn't, unfortunately. But rules are rules, regulations are regulations. This is what we have. And then to answer the second question, how many of these failed for Aspergillus? That would be an interesting analysis to do, and that's something that I probably should do. I would imagine, right, if you're seeing any appreciable level of mycotoxins, you're gonna see Aspergillus, um, or something like that, or total yeast, high levels of total yeast and mold. But again, we haven't done that analysis just yet. But I mean, if if a mycotoxin is there, it had to be produced by something. So I would assume you would see elevated levels of TYM, or it would have failed for Aspergillus already.
Thank you. That makes a lot of sense. And then we have another question now. Do live resin and solventless products have different levels of testing for toxins? So do we have different action limits for different matrices in cannabis?
Nope. Nope.
No.
And I think
Okay.
again, this is because, right, like we're still a young industry. Like and regulation is slow to happen and they're having a hard time keeping up. The industry itself moves super quickly. So I mean, I'm not throwing rocks at regulators at all. They have a difficult job and it's a moving target. So it do we have some adjustments to make? I think we do. Based on this data, there's probably some adjustments that do need to be made, just so that we're not doing things needlessly. I mean, cannabis testing is really expensive. And especially on the testing side right now, there are a lot of labs that are hurting. And really nobody is winning, right? Well, actually, that's not true. There are people that are winning, but they're not necessarily doing the right thing, unfortunately. So again, I think that there are adjustments that need to be made so that we do things that are sensible and make sense. Because right now there are a lot of things that we do that, in my opinion, just don't make sense, unfortunately.
Yeah. And while you were talking about total yeast and mold and now also like having different limits, like this also kind of fails to consider a large portion of this, which is like usage patterns and like frequency of use and like you were saying, specifically for the medical community and like patients who are using this for relief. There's a lot that is being failed to consider right now. And I think that um as an industry, we've kind of just like made a lot of broad general statements that we could have saved a lot of resources. Hopefully, going forward, we can use those resources for those specific targets. Okay, we have some more questions in the chat. Let's see.
Sure.
Oh yeah, which is kind of along the same lines. Would cumulative inhalation of these, even in low ppm, lead to issues over time? So now we're talking about usage and the accumulation. Um, would smoking have less mycotoxins present in the smoke than the aerosol in vapes due to its destructive method of consumption? Are there concerns about decomposition into other toxic chemicals under standard vaping or smoking conditions?
This is where I say, one, I'm not a medical doctor. Two, we need more research. I don't want to speak on something that I'm really not, I don't know the answer. I think it's fair to say that no one knows at this point. I think that chronic exposure, I mean, like I guess I would give the example, if someone has resided in a moldy house, or in their room has mold in it, and they start getting sick again, and they get sicker and sicker, I think it's fairly safe to infer that chronic exposure is bad, and it may cause it become worse, make you worse and worse the more you get exposed to it. The dose makes the poison. I think that's pretty, common phrase that's used and it makes sense. Um, now, I guess the other part of that was, sorry, um, like I guess, oh, about like vaping in terms of like,
Yeah, smoking
so,
versus vaping, and then the aerosol, its destructive nature of consumption.
okay, so like smoking versus vaping. So firstly, like remember these things are heat stable. I forget the exact points at which these degrade, but they were like in the 400 C range or 500 C range, I feel like when I was reviewing this. So yeah, it's they're going to stay in their form that they're in. Could they break down into something that is more harmful? Maybe. I don't know what their de thermal decomposition products are. Do these transfer into smoke? I think again, another area where we don't have that work to say one way or the other, or into the vapor. I don't know. So, but again, these are I'm trying to give people food for thought as far as like other areas as well that should be looked into. I think like a good example I could give, like I guess based on some of my own work that I've done in the past, was I saw that heavy metals were leaching out, and that those heavy metals end up, when I test the condensate and make kind of like a sort of a jerry-rigged smoke machine and capture that condensate, I recover those heavy metals. So the same thing could be asked here. Okay, well I spike in, or I see that there's mycotoxins in a product. I run it through that machine, I capture that condensate. Do those mycotoxins end up in your lungs? And then as far as health concerns with these things, like I think this is also an area where we're really lacking. Think about pesticide testing. I think it was Into the Weeds regulating pesticide testing in cannabis. That was the paper where they spoke to someone from the Department of Pesticide Regulation in California as to how they figured out what to set the action levels at. And they said we had literally no inhalation toxicology data to go off of. So we just set them at arbitrary numbers that were low, which again, another area, a huge area of we don't know. I think people like Jeff Raber, I think Jeff has done some of the preliminary work looking at pesticides and if they end up in the smoke. And I think, yes, they do end up in the smoke based on some work that I read a while ago. But again, there's like so many areas that are ripe for further investigation that we just don't have very much data on at all. Unfortunately, funding is scarce these days, especially with what's going on, kind of the political backdrop.
Accurate. Okay, we have two more questions. I'm going to try to make this quick. I'm going to skip to
Okay.
this one. Would a more high throughput detection method like ELISA that you mentioned allow for products to be tested for cheaper and more frequently and potentially alleviate some of these roadblocks?
Yeah, I mean, I think and I'm not as well versed in ELISA and what is available, but there's only like handful of these ELISA tests available, and they're not designed for cannabis. That's the problem. So you have to go through that validation to actually determine, right, if that's gonna be a feasible way of doing this. And I don't know that they have them for Fusarium mycotoxins. So if they do, wonderful. But if they don't, I just don't know. I think that they do have them for the major ones, the things like what we currently test for aflatoxins and ochratoxin. But as we saw in the data from Yasha, we really don't see those, at least in flower, very often, and they hardly exceed the 20 ppb threshold.
So maybe that would be another area of interest for future research.
Yeah.
And then someone asked, or someone says, I would presume there is a correlation between abundance of mycotoxins and abundance of certain fungi. How strong is that correlation?
Another area where I don't have, unfortunately, don't have that answer. Again, I think whereas that's kind of very similarly worded to the previous question, where it's like, where we saw yeast and mold failure, did we end up seeing, right? Mycotoxin hits or elevated mycotoxins. I think that's work that also still needs to be done. I think Yasha is actually on this call, so Yasha, maybe we could look into that too.
Great. Um, we're right at noon right now, but if there's any more questions, you can throw them in the chat. But other than that, thank you so much, Kyle. And thank you everyone for joining us and sending questions in. This will be available on YouTube afterwards. And don't forget to register for ACS before the prices go up in February on the 24th. So thank
Yep,
you,
and if you haven't
everybody.
voted already, vote
Oh, vote for the
for
can.
elections as well. Yes, can
Yes,
elections are the ballots close on February 7th, so you have 2 days.
thank you.
Thanks, everybody.
Have a nice day.